Hello, friends! Today we'll discuss the conditions for setup and hold times in digital circuits. Take a look at this digital circuit. It consists of two flip-flops with a digital circuit between them. Let me explain the operation of this circuit. The first flip-flop takes an input, and its output is connected to the digital circuit you see here. The output of the digital circuit then feeds into the second flip-flop. Both flip-flops are connected to the same clock. Now let's focus on the first clock rising. Assume that we don't change the input to the first flip-flop. After the first clock rising, the first flip-flop passes its input to its output, which goes to the digital circuit. If the digital circuit doesn't take too long, its output is Z. The second flip-flop captures its input, which is Y. But what matters is that it will capture the digital circuit's output when its input is the first flip-flop's output. Now let's move to the second clock rising. Assume we don't change the input to the first flip-flop. At the second clock rising, the output of the digital circuit, which is the input to the second flip-flop, moves to its output. Everything works fine as expected. Now assume the clock rising edges come too fast, so the digital circuit doesn't have enough time to calculate its output. During the first clock rising, the first flip-flop captures its input and moves it to its output, which becomes the digital circuit's input. The digital circuit then starts calculating to get its output, but as we said, it takes too long. Unfortunately, the second clock rising arrives while the digital circuit is still calculating, so its output isn't ready yet. So the second flip-flop captures an unknown value because the digital circuit is still processing its input, and the output isn't ready yet. And this is a setup time problem. The data was not stable long enough before the second clock rising, causing the second flip-flop to capture an incorrect value. To avoid a setup time problem, we need to make sure that the time between clock edges is long enough. This means the clock period must be greater than the sum of 3 key delays: the time it takes for the output of the first flip-flop to change after the clock edge, the maximum propagation delay of the logic circuit, and the setup time required for the second flip-flop to reliably capture the data. The T-clock Q launch time refers to the delay between the clock edge and the moment when the data at the input of a flip-flop is transferred to the output Q. The TPD logic max is the maximum time it takes for a signal to propagate through a digital circuit and produce an output. It represents the slowest delay path in the circuit. T-setup capture is the minimum time before the clock edge that the data must remain stable to be correctly captured by a flip-flop. Here we can see the timing diagram with yellow arrows pointing to the key times we discussed. These arrows highlight the important delays, such as the output delay from the first flip-flop, the propagation delay through the digital circuit, and the setup time required for the second flip-flop. Additionally, above the diagram, you can see T-clock, which represents the time between the two rising edges of the clock. Let's break down the hold time condition. T-hold capture is the minimum time after the clock edge that the input data must remain stable for proper capture by the flip-flop. T-clock Q launch is the time delay between the clock edge and when the output, Q, of the first flip-flop changes. TPD logic max is the maximum propagation delay through the digital logic between the flip-flops. This condition ensures that the data from the first flip-flop stays stable long enough for the second flip-flop to reliably capture it. Here, we see the timing diagram with yellow arrows pointing to the important timings and signals. The arrows highlight the clock signal, as well as the signal from the second flip-flop, showing the critical intervals and ensuring that the data remains stable for proper capture. Thank you for watching. If you found this video helpful, please subscribe for more content.